Hello friends and welcome to our lecture on marine pollution. In today's lecture, we will be talking about what's marine pollution, inputs and sources of marine pollution, effects of marine pollution that will be illustrated with some case studies, the possible ways to reduce the marine pollution, and finally the strategies for monitoring and management of oceans. To begin with, let me give you a brief introduction about the oceans. Oceans cover approximately 70% of the Earth's total surface area. In the total water content of Earth, 97% is present in the oceans. It harbors a rich source of biodiversity and its population may exceed in trillions. Oceans are the main regulatory agent of Earth's climate. About 60% of the world's population live within 60 km of coastal line and use the coastal line for their livelihood. It was thought that human beings living only 1/3 of the portion of globe cannot pollute this vast amount of water, as the marine ecosystems are capable of serving as sink for all the pollution caused by us. However, in reality this is not true. We have come to realize that our waste, even in small quantities, have huge effects on ocean communities and species. Now, the marine pollution. As per the UN definition, marine pollution is defined as the introduction by man, directly or indirectly, of substances or energy to the marine environment, resulting in deleterious effects such as hazards to human health, hindrance to the marine activities, impairment of the quality of seawater for various uses and reduction of amenities. It is known, however, that some pollutants can significantly alter marine ecosystems and cause harm, sometimes deadly, to species from the top to the bottom of the food web. Now, the major inputs of marine pollution. There are three main types of inputs of pollution into the ocean: coastal sources including river influx, atmospheric deposition, and offshore inputs. Coastal sources are either point sources or diffuse sources. The point sources include direct outfall through pipes discharging contaminated water from coastal industry, sewage discharges and development sites. Contrary to site-specific discharges, diffuse sources result from broad-scale activities, example agriculture and forestry, and are mostly associated with leakage of nutrients into groundwater, which are later transported into the sea. Both point and diffuse sources may also be located far away from the coast, in the upper reaches of a river, where contaminants are introduced into the water course. Via their estuaries, they carry possible large quantities of contaminants into the sea. Secondly, air emissions from planes are considered true atmospheric sources of marine pollution. However, they share certain features with pollutants that originally stem from either land-based or offshore activities. With respect to pollutants that are deposited through the atmosphere, two broad distinctions may be drawn. First, materials stay for either a short time or a long time in the atmosphere. In the case of the former, they are mostly deposited close to their sources. In the case of the latter, they are widely distributed on a regional or even a global scale. Secondly, substances usually enter the sea in rain. In contrast, particulate matter may also just fall out. So far we have talked about the coastal sources, point and diffuse sources, and atmospheric depositions. Now the offshore inputs. They mainly emanate from vessel source pollution. Although vessels contribute to the pollution of the marine environment in a variety of ways, the share of their overall contribution is not very large. It is about 10%. Now dear friends, we will discuss the main sources of marine pollution. There are about 5 major sources of marine pollution, and of all the sources, the largest is from runoff and the discharge on land masses. The smallest source is that related to offshore oil production. First, the oil pollution. It is mostly used to describe marine oil spills, where oil is released into the ocean or coastal waters. Oil spills are due to the following: crude oil from tankers, offshore platforms, drilling rigs and wells, spills of refined petroleum products such as gasoline, diesel, spill of any oil refuse or waste oil. The major contribution of 62% is due to the industrial waste. Refineries and terminals contribute 1%, natural sources 10%, tanker operation 7%, tanker accidents 3%. Other shipping activities add 15%, and the offshore incidents contribute 2% of the total oil pollution. During war times, particularly during World War II, the amount of oil put into the sea through the sinking of ships was very large. In all of this discussion, we all must remember that we potentially play our own role by the unintentional, yet nevertheless thoughtless disposal of old crankcase oil, which ultimately ends up in going down storm drains which lead to the ocean. In addition to the petroleum products that end up in the storm drains, a lot of plastic also take this route. Plastics are often discarded from recreational vessels, offshore platforms, etc., and end up either accumulating on the beach, in estuaries or salt marshes, or entangle marine animals that are attracted to potential food items. Many of the goods traded internationally are shipped as containerized cargo. Severe storms at sea sometimes causes the loss of some containers. One recent case was a shipment of tennis shoes in transit from Japan to the US. Several containers were lost and at least one broke open. Let us talk about heavy metal pollution now. Heavy metal is a member of a loosely defined subset of elements that exhibit metallic properties. It mainly includes the transition metals, some metalloids, lanthanides, and actinides. There is an alternative term for heavy metal, and it is called as toxic metal. The major sources of metals are either natural or man-made sources. There are several heavy metals that cause concern when they are found in the marine environment, like the erosion of oil-bearing rocks. The natural sources of heavy metal pollution is due to atmospheric inputs by wind-blown dust, volcanic activity, forest fires, riverine inputs into oceans, where the man-made sources are particularly due to the industrial discharge, sewage, resuspension of sediments by dredging and trenching. An example of mercury pollution in Minamata Bay, Japan. The source of mercury pollution was from the plastic plant dumped mercury chloride into the bay, and it was seen that shellfishes were contaminated with mercury, and people who consumed shellfish severely got affected, and it was reported that 43 people were dead and 700 were permanently disabled. The bay is still unusable for fishing and shell fishing. Impacts of metal pollution by bioaccumulation and biomagnification. Bioaccumulation is an increase in the concentration of substance in an organism or a part of that organism. The affected organism has a higher concentration of the substance than the concentration in the organism's surrounding environment. It is also called bioamplification, that is, increase in concentration of a substance in a food chain, but not in organism. Now the third source, municipal sewage. The leading source of marine pollution is runoff and discharge from land. The largest discharge from land is sewage, both industrial waste and sewage sludge. These waste products are either discharged by underwater pipes or dumped from barges. The effects of marine pollution happen on different scales of time and space depending on the organisms involved and the extent of the pollution. Another type of marine pollution is thermal pollution, or the changing of the temperature of seas or oceans. This can be caused by cooling water from power plants and industrial sites. Dear friends, let us discuss now the important issue, that shipping related threats to the marine environment. A wide range of different substances may pollute the marine environment. Many of these pollutants are released by vessels either operationally or accidentally. First, the operational pollution. Operational pollution denotes the phenomena that vessel source marine pollution is not confined to accidents. In fact, the majority of pollutants are released while the ship is on voyage rather than accidentally. In this respect, activities include the chronic discharge of sewage, tank residues, bunker oils and garbage, as well as the exchange of ballast water, emissions from vessel engines and pollution due to anti-fouling paints on ships' hulls. Discharge of soil debris, example deused packaging, is an even more serious concern, particularly in the coastal areas of developing countries. While the majority of sources, 60 to 80%, are land-based, the main offshore sources are fishing vessels and cruise ships. A large number of species is known to be seriously harmed and killed by plastic debris. Marine animals are mostly affected through entanglement in and ingestion of plastic litter. And the second one, accidental pollution. Polluting substances are released accidentally due to collisions, contacts with external objects, groundings, explosions, cargo transfer failures, sinking or loss of cargo. Ships often carry large quantities of cargo that's toxic or otherwise hazardous. The most evident example are oil tankers, which if involved in an accident may spill thousands of tons of crude oil. Yet oil is just one type of cargo that is dangerous for the marine environment. International Maritime Organization, in its efforts to enhance the safety of marine transport, has listed about 800 pollutants in Part 3 of International Maritime Dangerous Goods Code. The adverse effects of accidental spills of these substances range from mere reduction of amenities to severe hazards to human health and deterioration of marine habitats. The polluting effects of oil in the marine environment will be described in the next section. Now friends, we will be discussing the effects of marine pollution. The effects of marine pollution are very diverse. This is because the forms of marine pollution are very diverse. Organic matter, organisms that were alive but are not anymore when in the sea or ocean, causes a drop in dissolved oxygen. This can lead to the death of marine animals. These algal biomass can also release toxins that can kill fish and poison people. Human waste from sewage work, because of its fertilizing properties in plants, can cause algal blooms. Not only do these blooms cause discoloration of water, which looks horrible, it can also clog fish gills or even be toxic. The breakdown of algae also causes the drop of oxygen, as talked earlier. Ecological impacts of accidental oil spills are distinct and most critical. Typically, spilled oil separates over the surface of the water, forming a thin film. since large spills in the open ocean will often just burn off or disappear without detectable impact. Tanker accidents are most disaster close to land. The oil coats marine animals and birds at sea as well as the shallow subtidal and intertidal ecosystems close to the shore. Once the oil has drifted ashore, it poses a great danger to highly vulnerable ecosystems such as fixed vegetation, estuaries and oyster and mussel beds. Areas affected by this spill may suffer from it for many years, even when they appear to have completely recovered. If enough oil penetrates the sediments, hydrocarbons alter the long-ranging trends of community structure, particularly with respect to microalgae and worms. The toxic chemicals in the oil can cause physiological damage, which can include change of behavior. It can also damage the reproductive systems, which has an effect on the population of a species. It is also an eyesore and tar balls created on beaches and are very difficult to clean up. Human waste gets into water via many ways, can increase the concentration of pathogenic microorganisms in that part of the sea. Filter feeding bicuspid marine animals like mussels, clams and oysters concentrate pathogens in their gut. So, eating these animals from polluted waters has a health risk. The discharge of sewage is a ubiquitous problem and may cause severe bacteriological pollution, harming local fisheries and aquaculture, and in some areas leading to an excess of nutrients. Sediments from mining, forestry and farming cause the water to become cloudy. This can harm photosynthesis underwater. It can also bury marine habitats, which can kill fish and other marine species such as coral. Pesticides like DDT and other chemicals run into rivers and through the food chain, built up in large quantities in marine mammals and birds, and cause them to have a reproductive failure, which causes a decline in the number of these marine mammals and birds. Chemicals which are painted onto the side of boats to prevent growth of marine organisms often seep into the sea. These pollutants can affect animal life, especially in places of high traffic like harbors and marinas. Alien species compete with native species for food resources, etc., can kill off native species and reduce biological diversity. To add to all this, these species can introduce new marine disease. One of the most dangerous pollutants to marine life is plastics. Items like plastic bottles and bags kill marine animals due to choking and suffocation as they eat them thinking that they are food. Other animals are also killed by getting tangled in plastic items. Other miscellaneous items littered into the sea also can harm marine life. For instance, discarded fishing nets continue to catch fish and so kill fish that are not even going to be consumed. The plastic debris on beaches can last up to 400 years. Radioactive substances also pollute underwater. These substances can enter in food chain and cause disease in marine life. Thermal pollution can kill temperature sensitive marine species such as coral. It can also confuse and displace marine animals. Now, the physical damage to marine environment. Even without causing pollution of the marine environment, ships can harm oceanic habitats and wildlife by direct physical impact. Physical impacts on habitats are caused by anchors and grounding of ships. Coral reefs are particularly at risk from groundings and anchoring. With respect to the latter, damage is caused either by the direct impact of anchors or from the dragging and swinging of large anchor cables and chains. Friends, there are a number of ways by which we can reduce marine pollution. Organize the beach cleanup, take care of a local stream, reduce your rubbish. Now the management and monitoring of marine pollution. There are also the number of ways by which we can manage and accordingly monitor the marine pollution. Advances in science and technology are needed for the management of contaminated sediments. Monitoring is key to fighting nutrient pollution. Cleanup strategies require careful study. Institutes like Department of Ocean Development, Government of India in marine pollution monitoring have to play active role. In conclusion, we can say that ocean pollution is a diffuse, complex series of problems that are not easily addressed. Nevertheless, some pollution problems can and have been successfully addressed. Because of the value of science in dealing with pollution, there is a need to devote resources to research, improved monitoring, and the continued development of pollution source reduction strategies and technologies. Efforts will be made more effective when actions at all levels of government, federal, state and local are better coordinated, and when communications to the public about pollution sources and impacts are improved. With this, we conclude today's topic, that was marine pollution.